You're listening to Design Atlas Season 3.
Have you ever wondered what kinds of technologies are used at an observatory? After all, an observatory telescope is just a large magnifying glass that helps us take a peek into the night sky. Or is it? In the 21st century, the observatories we have built around the globe and the telescopes we've sent into space, like Hubble and James Webb, are highly capable, taking numerous photos autonomously and using new and cutting-edge technologies to capture some of the most striking images of our galaxy, the Milky Way, and deep into the cosmos to help us further understand this vast universe we are a part of.
I'm looking at something that happened billions of years ago that traveled so far, and I'm currently looking at its light. That's just always the best bit. I don't know, it's just really cool.
That's Eloise Moore, a Master's of Astrophysics student at the University of Western Australia and a telescope technician at the Zadko Observatory. While Eloise's background is not in design or a true purely creative industry, the way in which she applies creativity and elements of photography to her work are quite inspiring.
After our discussion with Bray Falls on astrophotography, we wanted to dive deeper into understanding just how scientists and astronomers use telescope technologies to further expand our knowledge of the universe. As designers, we all have a unique ability to understand and translate information, oftentimes complex information, and simplify it down for an end user or audience, all while making it visually beautiful. While you're listening to Eloise's story, we want to challenge you, our listeners, to think about how your skills could help communicate her work and her story to a wider audience. We've done the first step by bringing her story to you. What will you do with it next?
I guess I've always been super interested in space ever since I can remember. I used to look up at the night sky and try and understand what was going on, and it sort of led me into reading books, reading more, then a degree, now a master's, and pretty much is my life essentially.
Currently, Eloise is studying high-energy astrophysics, and while we could try to explain the concepts to you in this narration, we think it's better left for Eloise to explain.
My master's is focusing on high energy astrophysics, which is the study of sort of the most extreme phenomena in the universe, which produce or use very high or vast amounts of energies. So this could be things like supernova, black holes, neutron stars, really big explosions. For me, what I really like are my research supervisor told me not to talk too much about this, but it's my favorite thing. It's the highest energy particles in the universe, and they're called ultra high energy cosmic rays. And essentially, think about something as tiny as a proton, absolutely tiny, and it has the same energy as a bullet fired from a gun. So when you think about a size to energy ratio, that is absolutely tremendous. And what I'm really interested in is understanding how they get such incredible energies and where. The Large Hadron Collider is a really big particle accelerator in Switzerland with CERN, and they can accelerate particles to, I think I did the maths, and it's a billion times less than an ultra high energy cosmic ray. So that's absolutely insane. So basically, the universe is one great big particle accelerator, and it can provide so much more information, which is why it's so vital to understand, because it just tests these extremes of physics, and it can give us like this probe into how everything works essentially.
On the side of her studies, she's been an active contributor to the Zadko Observatory, which is located not too far away from the University of Western Australia. The stars simply aligned for her and how she ended up starting as a technician at the observatory.
It started off as an internship in my second year of uni, and it kind of never ended. I'm now a member of the team and a technician. So I started doing something completely unrelated. And then my supervisor took me up to the observatory one time and realized I was actually really interested in how everything worked. And I kept going back up, and yeah, I don't really know where it started, but it just sort of never ended. Yeah, it's great. Now I get paid to fiddle with space things, so, not really complain.
While there are many observatories for students to use to learn and gain experience in operating telescopes to look up at the night sky, the Zadko Observatory is purely meant for research purposes only.
It's with the university. It's a research facility, so there's other telescopes for the university for students to do assignments on, but this one's for purely research purposes. So the main scientific goals of the observatory I work at is to look at transient objects in the universe. So this is basically objects that sort of come and go in the sky, like a supernova or something like that. In terms of observations and stuff, we work with a lot of different facilities in the world. So we have done some observations for the European Space Agency to do with things like space situational awareness. So looking at things like great big asteroids in space that could potentially, come into the Earth, or even a satellite launch, if they want us to track it, make sure it's going okay, that sort of thing. But we also receive it's kind of like a pager notification from NASA from this mission called the Swift satellite, and it's a satellite observatory that looks at these very energetic explosions called gamma ray bursts. And so what happens is the sort of robotic telescope will receive this pager message almost, and it'll automatically then move to the object if it's in the sky where we can see it and start taking observations. And also, anyone else who requests access can make a request before the night, and it gets put into the sort of list of objects that we look at as well. So there's lots of different things.
The telescope at the Zadko Observatory is a 1 meter in diameter telescope. As a telescope technician, there are a lot of various tasks that Eloise needs to pay attention to.
So a big thing is general optical maintenance. So say over time a screw comes a little bit loose, the mirror can move a little bit, you'll have to readjust that, try and get the mirror in place and make sure everything's aligned so that way everything's in focus again. And optics is really finicky, so it's a pretty big job. The observatory I work at is in the middle of the Australian bush. So it's a really harsh environment, it's really hot, there's sometimes bushfires, there's sometimes power outages. It can also be really humid, and so electronics will start to deteriorate over time. So you have to replace some electronics and debug what's going on. And on top of that, you also have to maintain the computers that run these telescopes. So that's also a lot of work. So it's actually lots of different things. It really depends on what breaks.
As an observatory technician, the job also provides Eloise with a few surprises from time to time.
One of the funniest repairs that I had was one of the cameras on site. It's like a special CCD camera used for astronomical imaging. And we noticed it was being a bit funny. And we went up, had a look, took it apart, and there was a great big bug that had died in it. So and so we had to take this thing apart, and we just find this fried bug in there. So sometimes you just get the weirdest things, like, this isn't something you can plan for.
Photography is generally considered an art form. There are a lot of elements to good photography that go unnoticed when observing a photographer. Think about it: the angle, the light source, the color, the focus, and so much more. For Eloise, she also has quite a process for taking photos of the night sky.
There's a couple of things going on with that. We primarily have a web interface, so anyone who wants to make a request can go into that web interface, say the object, say what sort of filters they want to look at it through. It'll go through our robotic system, and it'll look at the coordinates, work out when it appears in the sky, compare it with all the other requests that's been made, and then make like a sort of list based off what, like, you know, sort of like what can be seen one after the other. And then on top of that, getting these things from NASA, these sort of almost pager things, also gets fed into the system. And these are seen as a very high priority object because, you know, it's really cool and randomly happens. Yeah, so then that'll get passed into that pipeline as well. And then we may have to move another lower priority object to another night or later on or something like that to get this insane transient that's, you know, just been detected. So
scientists and researchers all over the world in the field of astronomy have access to making requests to the Zadko Observatory. The researchers request a specific coordinates. Zadko even gets requests from NASA from time to time.
It's all done via the computer, via code automatically. We don't need to do anything. You can operate it completely remotely. If you do want to be there on site, we have to turn off the whole automatic operations thing, and then you can manually put in coordinates and stuff like that, but it means having to go up on site, and it's a lot easier to do it remotely, so that's what we prefer to do. So essentially, when we look at an object in space, we read light. That's all. So we use these special cameras called CCD cameras. And what happens is that the light sort of comes into the camera, and then we read out the intensity of the light. And the image that we end up with is a black and white image, which looks really boring. It's not the pretty ones that you see in Google Images. And as the telescope is taking these images, it sort of tracks it very slowly at the same rate as the motion of the Earth. So that way it doesn't appear like a blurred line on the image. I mean, you can do that as well for very specific, like, wacky things, but typically you don't. So yeah, it's a black and white image with lots of dots. The filters are really useful because essentially it filters out certain wavelengths of light. So then you can see the intensity of, say, light more in the red region, the blue region, infrared, that sort of thing. And then you can stack them together and create those beautiful colored images that you see, but you can also do a lot of science with it. So different processes in physics will emit different wavelengths of light. And so you look at things through different wavelengths and you can kind of see sort of different structure depending on what's going on, because obviously different wavelengths have different frequencies which travel differently through space. So you can actually see a lot of different things by using different filters. A really good example is when you're looking at a galaxy. If you look at it in optical, you just sort of see a really pretty galaxy. But if you look at it in, say, X-ray, you don't see the galaxy itself, but you see this really bright thing in the center. And that corresponds to X-ray emission of the black hole in the middle. And so, yeah, using filters or looking at different wavelengths of light lets you see lots of different things going on. So that's super important when you're doing research with an optical telescope. It's really cool.
Looking up at the night sky gives Eloise a feeling that nothing else can. There is so much to learn out there. What really is out there?
I don't know, for me, it sort of provides like this sense of like intrigue, because it just shows just how much more there is out there than what you know on Earth. And that just makes it super, because you're like, what's out there, you know, for only this tiny grain of sand, there's so much more out there yet to be discovered. It's, you know, it's like the early explorers exploring the Earth, you know, like, oh, we have this really great country here, but what if there's more out there, you know, waiting to be discovered? Yeah, it's basically that sort of thing.
For Eloise, seeing the light hitting her eyes when gazing up at the night sky from the Zadko Observatory can be quite a surreal experience. Here's why.
It only takes light, you know, 12.469 billion years, traveling at a 3 with 8 zeros meters per second. You know, when you're looking at stuff like that, you're thinking, I'm looking at something that happened billions of years ago that traveled so far, and I'm currently looking at its light. That's just always the best bit. I don't know, it's just really cool.
As we prefaced at the beginning of this episode, even though Eloise is not technically seen as a creative individual by the general public, we beg to differ. By exploring the galaxies and the vastness of space, Eloise requires ample creative thought to solve and also identify the mysteries that lie beyond our atmosphere.
Creativity emerges in all disciplines, no matter the title. And what better place to find it emerge within Eloise's work as she looks out into the vastness of space to ask the questions that lead her to the answers we as human species seek.
Join us for next week's episode as we meet with Ivan Tomachev, a former user experience designer at Blue Origin. If you'd like to support the show or to learn more about Design Atlas, please visit our website, designatlaspod.com. To get in touch with us, DM us on Instagram or tweet us at designatlaspod, or send us an email at hello@designatlaspod.com. You can also join the Design Atlas Slack community to connect with our show guests and get behind the scenes content and the latest design resources. Link is in the show notes. Finally, don't forget to subscribe to the show so you don't miss out on the next episodes. We would really appreciate if you could give us an honest review about the show. Thanks again for listening to Design Atlas.